I guess we're on already. So we'll start. This will be the third or the fourth video that I have, no, before anything else. Tagan kay tag mga series of videos nga gi-upload, and I hope you are opening it and learning from it, at the same time enjoying from that video. So what we are going to do now is to tackle what we call route distribution. Saan siya sa component sa akong final exam, para pag abot na to during the finals, dili na ta dili na ta mag problema. At the same time, this is good kay pabalik-balik pa jud ninyo ang video, right? Sige. So we will be tackling route distribution, and we are going to redistribute the static or EIGRP and OSPF. So what really is a route distribution? So basically, the use of routing protocol to advertise route that are learned by some other means, such as another routing protocol, static routes, or directly connected routes are called distribution. So pasabota na is in order for you to advertise your protocol from one protocol to another protocol, sama ko no sa static to EIGRP to OSPF. So kung i-advertise na nimo and that protocol learn that there is a new protocol set up, so pasabutan na, we call it the redistribution. Okay, so why are we usually performing redistribution? So it says there, if your protocol is running throughout your entire network is desirable, pero pag abutan na sa pikas company, dili dyan na siya makita. Okay, most routing protocol is common for a number of reasons, such as one, company mergers. So example, na kay network nimo okay sa imong network, but sa pikas dili. Why? Because the protocol in between is not set nga para magkita silang duha. So alangan mga paggonto nimong isa nga iingnon nimo nga okay, i-follow lang ako, it can never happen, or else ipo na sad to hagbaon tanan nilang setup, right? Or the other way around, ikaw na sad mo palong sa imong setup para lang to accommodate them. So basically, those are the reasons why, no? So running different protocol routings or different routing protocols is often part of network design. So before pa ka mo identify or before pa ka mo put up sa imong network, you know already kung unsa nga klase protocol ang gamiton nimo. And you have already the idea nga, let's say for example, University of St. Carlos would like to connect to UP, and we don't know what the protocol UP is using, and UP doesn't know what protocol we are using. Okay, ikadua, let's say for example computer science and computer engineering. So basically, let's say for example sa computer science, ako pag set up na ako dito, I'm using RIP to do that, but in computer engineering I use their CIGRP nga naman, because the router is Cisco. My router here is Microtech. So unsahon na nako pag merge or pag may communicate ang duha. That's why a redistribution is a necessary dyan na siya kaayo. Okay, so to continue, differences in routing protocol have protocol characteristics. So different protocols have different characteristics. Sama sa number one, makaingon ba ang OSPF the same as RIP the same as EIGRP, or so on and so forth? We cannot do that. Nga naman, kilalahi man na sila characteristic ng klase mga protocol. Like for example, what are the characteristics? Number one, laylay sa metric, right? Magintag metric, there are different metrics that each protocol uses so that they can communicate. Like for example, saan na lang daan, if we are using RIP, the metric used in RIP is number of hop counts or number of hops. So basically, mao na yung metric nya. Is the administrative distance similar across different protocols? No. We know already that the administrative distance of RIP is totally different from EIGRP. No? Are they using classful and classless addressing? No. So those are the different protocol characteristics that we must consider in order for us to perform successful redistribution. So consideration must be given to these differences so that the redistribution should be successful. Okay, so there's a need for route distribution. Number one, as what I have told you, natay mga company merger. So nga naman ma-redistribute mo yun ta. So let's say for example, Kyocera and Epson nag-merge sila. So don't tell me mo bow down si Kyocera sa kang Epson or si Epson sa kang Kyocera pag nguniatan niyang network para lang to accommodate the network of the other. So it cannot happen. So na may redistribution nga nung dili lang nimo redistribute niya. Secondly, different departments under different administrative control. Like for example, if the USC TNS, IRM TNS would like to communicate with us in ComSci, so dili na siya kinahanglan pa mo change sa iyang protocol, but rather iyan na lang i-redistribute yung protocol from us to them. Okay, connecting to partner networks. What I did in what you call this, dito sa LiDAR, my protocol is set as EIGRP because I'm using a I'm using a Cisco router, but sa UP is different. So mo to pag connect na mo, redistribution gigamit na mo, then tunneling. Okay, another is extranet configuration. So extranet configuration, like for example, our intranet is USCTC, right? Intranet na nato, but USCDC or the downtown campus is the extranet of our organization. Although although they are sister schools, but in the downtown campus uses different network addressing, uses different protocols. So nga mong gibuhat is extranet configuration para magka-communicate sila, so mag-redistribute ta. Then the other one is IGP routes to be advertised in the BGO. Okay, so later ato nang panon, no. Next, kinahanglan ko, no, if you are going to redistribute both of your protocols router to router, kinahanglan it will be a mutual redistribution. Sa man ipasabot sa mutual redistribution, if you are going to redistribute the EIGRP to SPF, basically you are going to redistribute the SPF to the EIGRP. We call it the EIGRP to SPF and vice versa. That's mutual redistribution. Dili lang pwede one way. Kaya kung one way lang na siya, how about USPF can communicate with the EIGRP? Din na pwede. So kinanglan, ibutang nimo, the idea is you are going to put OSPF inside an EIGRP. So once it is already converted, ang EIGRP na po isulod nimo sa OSPF. Okay, so that's the idea. Same is true with the EIGRP to RIP, RIP to EIGRP, RIP to SPF, or SPF to RIP, so on and so forth. Okay, so two-way process na siya. Pili lang kay usa lang away. Next, redistribution options. Redistribution is not just between routing protocols. No? We have multiple options between routing protocols, RIP, SPF, EIGRP, and BGP. Okay, so mo ni siya ang pwede nato makuha. Also, we can use that in static route. A static route can be redistributed also in a routing protocol. Bantay ka na natay default route. Kung nakay default route, unsaon na karong pagkaila ni outer protocol connected to that protocol nga na ay static route. So para ma-redistribute nimo ang protocol nga inana, imo yun siyang i-redistribute static. But later on, ako dyan na siya i-capitalize kung unsaon na ito pag-redistribute sa static. Okay? Directly connected routes can be redistributed to a routing protocol also. Okay? So these are your options. But most commonly, mao ni siya ang duhang atong gigamit between routing protocols and static routes. Kaning directly connected routes can be redistributed into a routing protocol. Seldom lang na siya gigamit because you have already applied this one. Okay? Next, inclusion of redistribution, kinahanglan kabalo jud kita kung unsa ning gitawag nato ng mga metrics. Okay. As far as I know, and as far as my experience is concerned, okay, kinahanglan if you are going to convert EIGRP to become RIP, you have to also convert the bandwidth and delay to become a hop count, or the other way around, a hop count to become an EIGRP. Like you convert the hop count to become bandwidth and delay, and cost and bandwidth and delay, or cost to hop count. So basically, you have to understand that each protocol have different characteristic. So number one, kung gagamit kag RIP, basically ang metric nga gigamit nato is hop count. So later explain na nato kung side the difference. EIGRP, bandwidth and delay, and OSPF to cost. You know that one already. Basically the cost here is that includes the bandwidth. Okay, next. Redistribution syntax. Importante yung that when you are going to perform redistribution, you must understand, no? You have to follow the syntax. Sayop-sayop ang imong pagsabot sa kada syntax, then it will become disaster. Dili mao ang pagka-redistribute nimo. Okay? So to implement a mutual redistribution, follow the correct syntax. So what is the syntax if you are going to convert RIP to become EIGRP or vice versa, OSPF to become EIGRP or vice versa, or RIP to become OSPF and vice versa. Okay? Sige. Now, continue. Now, let's try to redistribute an RIP to become EIGRP. So, RIP to become EIGRP. So, all you have to do is to give the command redistribute. This will be your command. In EIGRP, there is a target protocol from RIP. So, meaning, isulod ko nun mo, you are going to put the EIGRP inside an RIP protocol. Then, afterwards, there is an ASN there. That is the autonomous system number assigned to the EIGRP, right? And you have to identify what metric are we going to use and the default metric value. So the default metric value is always 1. Okay? 1 yun na siya permanente. Pwede ka maggamit og any other number, but usually kay ang imong tawagan ni RIP is naka-default na into 1, so meaning you don't need to change it anymore. Okay? So timan na to kaning mga commands, then you have to give the command inside your router RIP version 2, then you have to give the command redistribute EIGRP 10 metric 1. Then that's the time that the EIGRP can now become an RIP, or not become an RIP, but basically can be read by RIP. Okay, next, EIGRP to RIP. Ang EIGRP to RIP kanilisod-lisod niya. Okay, kay daghan kaayong components or characteristic ang EIGRP, no? Ang RIP nimo gamay raman, di ba? Metric 1 lang, default value pa jud, but in EIGRP is different. Now, let's say for example, redistribute metric, okay, redistribute RIP, whether it is version 1 or version 2, automatic na siya. So redistribute RIP metric. Okay, redistribute is the command, RIP is the target protocol from EIGRP. The metric, hatag yung command for the metric. Then the bandwidth, okay, the bandwidth metric in kilobit per second. Usually, mohatag yung command na number na inani, no? That is 4.2 billion ang iyahang bandwidth. But the bandwidth is based upon the interface bandwidth that you are using. So the bandwidth metric would be 100,000. Okay? Mamto interface bandwidth na to by default. That's 100,000. The delay metric is another thing. So the delay metric is the EIGRP delay metric in 10 microseconds per unit. So pasabutan na, there will be something, a delay, when the what you call this, the data is being propagated to the internet or to the network. So paglabangan na dito dapita sa TCAS router, so there is a delay there. So usually ang ibutang nako ana nga delay is the default one, the 10 microsecond units. So makuha naman just follow lang. So reliability metric. Sa reliability metric, this is an EIGRP metric where 255 is 100% reliable. So meaning, between the two connections that you have from one router to another, so ang connection mo reliable ba na? Yes or no? So may nga reliable, that's 100%. So you have to give the number 255. So kung butalan nimo as 0 or 1, meaning it's not reliable. Okay, you get the point? Okay, next. Sa load metric. Load metric is an EIGRP effective bandwidth metric. That is the loading part, where 255 is 100% loaded. So pasabutan na between your what you call this, kaning linya nimo, no, between your router, nanay load diha. So ang load na unsa ka bugaton sa data from one router to another router to be propagated through your cable. So pasabot na is if you have 255, that's 100% loaded. Half of it is what? 125, right? Or 120. So that is 50% loaded. So, mo nang akong ibutang diya is it's either 0 or 1. Para moingon siya nga, kung 1 akong ibutang, mas lesser ang loading. Klaro? Then, the MTU path metric. Sa MTU path metric, usually, mauni siya ang tawagan niya I can hardly explain it kay wala mangugo sa router good, but basically yan yung na ako'y term na kalimot ko, para nevertheless later makita na nato, but the value that I'm going to use for the MTU path is always 1500 as the default. Okay, 1500 is the value which the metric unit is using every time mo communicate siya from one port to another port. Okay, so example of a command would be router. You should be inside the EIGRP. Okay, router EIGRP 10 redistribute RIP or RIP the metric of 100,000 with a delay of 10 with the reliability of 100%. Okay, or with the reliability of 255 if you would like to. 100 half lang na, di ba? So kung mo kag 255, so mo na 100% reliability niya. Then you have a load of 1 para makaingon ang network na oy dili na siya loaded ang kaninga line. Then with the MTU of 1500. Okay? Sige. Follow. How about to redistribute RIP to OSPF? Simple lang kayong RIP to OSPF. So mayroon kag router RIP, then redistribute to SPF, then you identify the PID number, which is the target protocol, which is the process ID number, right? Then the metric, then the default value. So pareho lang yapon siya, mura na siya og RIP. So if you are at the RIP, so mayroon ka lang redistribute to SPF1 metric 1. Okay, sige. How about SPF2 RIP? Pareho lang sila, no? Pareho lang sila, pero kalahi. So, redistribute RIP metric default value, then na kay subnets. So pasabutan na, if you are not going to wala man tay problema, redistribute sa command, RIP is the target protocol from OSPF, then metric value is the metric for the distributed routes, then the default value is 1, then subnets is consider subnets for the distribution to SPF. So pasabutan na kung dili ka mohatag og subnets, ang iyahang ipang-appeal dito sa iyahang redistribution are the classful addresses. So katong imong mga gipang subnets bali wala to. So mo nang butangan yun mo siya og component ng subnets. So example na ako sa router OSPF redistribute RIP metric 1 subnet. Okay, I hope nakuha. Pero you don't have to worry, makuha man na to. What I am showing you is the syntax on how to redistribute. Okay, next, redistribute EIGRP to SPF. Kabantay mo, pareho-pareho lang siya sa redistribute EIGRP to RIP. Lisod-lisod siya, pero maaman dyan na. Hindi naman takakuha na, no? So again, redistribute to SPF, then PID, which is the process ID, metric, the bandwidth, the delay, reliability, load metric, then the MTU path metric. So again, the distribute is the command, OSPF is target protocol, PID is the process ID, the metric is these are all the metric. Okay, so the delay of bandwidth, the bandwidth that we are going to use is the default of 100,000, then 10 is the microsecond units for the delay, the reliability is 255, the load metric is 1 for the least loaded, then the MTU path metric is 1500s or 1500. So meaning redistribute SPF1, the metric of the bandwidth, this is your delay, this is your reliability, and this is your loaded metric, and this is your MTU. Okay, next, how to redistribute RIP to OSPF. Pare-pareho lang sila, no? So, redistribute, ah, how to redistribute OSPF to EIGRP, I mean. So, this is EIGRP ato. Susbon. Sorry. To EIGRP. So, target protocol. So, sayon lang siya, no? Ang EIGRP to become RIP. So, kaya moingon naman ka og redistribute EIGRP 10 if your EIGRP is numbered as 10, then the metric redistribute, then the value of 1. So, redistribute EIGRP 10 metric 1. Okay? So, the metric field has a number of different meanings. No? The metric field indicates the cost of a route. So always remember nga, di ba naman ito yung mga metric ato, then daghan kag metric. So nakatay metric value. So each of these protocol have different metric values. Mao to'y dapat natong sabton kung unsa ni silang mga components so that we can understand how does the protocol change its metric value to accommodate other protocol. So if multiple routes exist to a given destination network ID, the metric value is used to decide which route is to be taken. So, klaro man kaayo, no? So, imagine na kung if yung router nimo, if your router would like to communicate with other router and determine the best path, unsa may gamiton, the metric value jud, no, to determine what's the best path. The route with the lowest metric is the preferred route. So, klaro na kaayo. Kung sa OSPF pa na siya, pasabutan na kung what is the least, diba? Sa tong list na to, depende kung unsa nga linya ang gigamit. Like for example, pass Ethernet or serial connection. Mao to yang cost, right? Some routing algorithms only store a single route to any network ID in the routing table when multiple routes exist. That's true. In case of a metric used, in case the metric is used by the router to decide which route to store in the routing table. So always remember nga mauning mga metric na to, if you can remember the OSPF, no, tulo ka agihanan, kaniyang agihanan cost about 100, kaniyang agihanan cost 50, kaniyang agihanan cost about 12. Asa iyang gamiton nga ibutang niya sa routing table katong pinaka-list, ibutang niya dito ang route na 12 because the cost of that route is lesser than the other. So mo na siya ang iyang purpose of the metric field. Take note that each metric can be indicated in different ways expressing what route preference that you use. Like for example, if you are using RIP, kagamit yung kag hop count. So hop count is a common metric. It indicates a number of routers hops in the path to the network ID. A hop is a metric value used to measure the distance based on the number of networks a packet traverses. So, if you have 10 routers, magsige na siya jump from one router to another until it reaches the destination, mauna niya i-count na hop count. So, the lesser the hop count, the better, as long as it can reach the destination. So, each time a router forwards a packet into the segment, this counts as a single hop. Okay? A router protocol that observes hop as their primary metric value consider the best and the preferred path. When a multiple path exists to a destination to be the one with the least number of network hop. So, klaro kaayo nga kung unsay pinaka-least nga hop, mao na ibutang niya sa routing table. Okay? So, let's say for example, if you want to go to user A would like to go to user B, so pasabot ana, moagi siya this way, so, and this way, di ba? So, either R1, R3, R5, or R1, R2, R4, R5. So, if you are determining a hop count, which would be the best path? So, klaro man kaayo nga, the best path would be the least hop count, right? So, that would be R1, R3, R5, then user B. So, mo na siya ang ibutang niya sa routing table. Okay? So, I hope nakuha na to. Next, we have bandwidth. Okay? A metric bandwidth. So, protocols that consider the capacity of a link used in this metric. So, klaro kaayo nga magyung tag bandwidth depende jud sa link nga gigamit or sa linya nga gigamit in between your router. So, bandwidth is measured in terms of bit per second. Okay? The link that supports higher transfer like gigabit are preferred over a lower capacity like 56 kb. And 56 kb usually money serial connection, no? And kung gagamit ka gigabit ethernet nimo, so pasabotan na mo na ipaspas. This protocol determines and consider the bandwidth capacity which link along the path end to end. The path with the overall higher bandwidth is chosen as the best route. Take note, no? Yan ang computon gihapon kung pila ang bandwidth from end to end. So if you have 5 routers compared to 3 routers, and if you total the entire bandwidth of 5 routers which is lesser than the 3 routers, mas maayo pa to ang 5 routers rather than 3 routers. Mao tay best path. So sometimes kung nag-ingon jud sa balaod, no, that the shortest path may not be the best path. So shortest path lagi itong 3 routers, pero dako man sa bandwidth nga gigamit rather than 5 routers, no? 5 ka router ang iyahang giambakan, pero pag compute niya sa bandwidth mas lesser man. So meaning mao to ang iyang gamiton as the preference. Next, the delay. The delay is measured in tens of microseconds. The symbol mu is used to indicate this. This is a Greek letter mu. Okay. Delay represents the amount of time it takes for a router to process a queue, no, and transmit a datagram out of the interface. So pasabutan na when a port to port communicate with each other, and when a router basically pass the data, no, to the interface and to the link, na dyan nag-delay nga 10 microseconds always. Delay dyan na sa pack, wala delay, automatic na dayon diretso, no? It's not. Yung ano man, syempre, i-determine pa na niya if the link is in use, if the link is busy, so on and so forth. So na ay delay nga ginagmay. So protocols that uses this metric must determine the delay value of all the links along the path, na from end to end, considering the path with the lowest cumulative delay to be a better route. So same is true with the EIGRP, no? Kung kwintahon niya tanang delay, take note, dili lang 10 microseconds ang delay, ha? That's the minimum ra na siya. So meaning, what if ang link gigamit pa, paggamit sa link ana, 10 microseconds naman na, so may 100 microseconds nagulat imong router to send, kaya because the line is still busy. So mo na siya nga i-accumulate na niya pila ang delay, mao na siya yung best path. Okay, so delay is also a part of the the properties of an EIGRP. Next, reliability. Mao na siya akong i-explain niya. The reliability, although this metric may be configured as fixed value by the administrator, no, but sometimes it's generally measured dynamically over specific time, specific periods, just 5 seconds. So, reliability. So, how reliable a line is when it comes to connecting from point to point. Okay? So, links experiencing more problem would be considered as less reliable. So, take note nga ang ato ang router, kung naa kay gamay nga problema or wala jud problema, mas nindot siya. Okay? Pero kung imong link experiencing more problem, would be considered as less reliable. Problemado. Correct? So, mo na siya nga you have the value there determining na you know already that this line here is always performing not good. So, imo dyan na siya ibutang dito. And because the network conditions are constantly changing, link reliability will change. This value is generally measured as percentage of 255. Okay? With 255 is the most reliable and 1 being less reliable. So, pasabutan na, butang kog 1, di yun ni maayo nga path. So, meaning, ang imong router, padulong yun sa laing path. Okay? You get the idea. Sometimes, gamito na siya sa ubang networker, mga di ko ganahan mo paagi diri sa ako, that's why I put it less reliable. Pero, it will affect also the reliability of your network pod. Okay? Sa mong iro. Dili na mong iro. Yan na sa iro o silingan. Sa amo kayo. Okay, then secondly, next, the load. Di ba kabantay mo ito, the load metric? The load is a variable value generally measured over 5 seconds window indicating traffic load over the specific link. So, meaning, sa kana nga link nimo, you have the link between router to router, yan ang nagkikwinta nga daan pila ang load na every 5 seconds. Okay, so if it is loaded, so pasabutan na the value is utilized. Okay, 100% of that line is being utilized. So mo na siya nga, when you are going to perform load measures, the amount of traffic occupying the link over this time frame as a percentage of a link total capacity. Okay, means that when you are going to make use of this line, basically all data passes through there, so busy yun siya, it is loaded. So the value of 255 is equivalent to 100%. So may yung 100% load, bugat siya. Okay, that the traffic is very high, okay, and the bandwidth utilization is also very high. So ang imong buhaton diya, you have to lower your load into, let's say for example 10, 1, so on and so forth, so that this line, when your router sees na oy diri ko moagi na I'm going to pass through here in this link, so it says there, oy the load is not that very heavy, so diri siya mo-pass through. Okay, so that's the meaning of load. Cost is network administrator can affect ways router make path decision by setting arbitrary metric values. So pasabutan na pwede rin mo masultian yun si router nga okay diri ka moagi ka because ang akong iset na tawag gani, ang akong iset na bandwidth diri is much higher compared to this link here. You get the idea? So mingon ko sa S00 I put a bandwidth of 64,000 rather than 54,000. So meaning moagi siya dito sa PP4, compute na niya until sa time it reaches the pinaka end. These arbitrary values are typical single integers with lower values indicating better path. So pasabutan na the least value of that path is the better path. Okay, always remember kung may sure kung gagamit ko og one serial link compared to what we call this Ethernet link and fast Ethernet link, so asa man na mas lesser ana dili ko sa fast Ethernet kay nga naman that's 100,000 divided by 100,000, a preferred bandwidth over the interface bandwidth mo na siyang formula ana, di ba giisgutan naman nato last. So the lesser the value the better, that will be the best path. Okay, this is the MTU now, the maximum transmission unit. So MTU is advertised when a routing updates and when you have an equal path in the same destination, MTU comes in play. So let's say for example na ako'y duwa ka path, no? So it determines now pareho ni sila asa man ko moagi jud kung ako pay protocol unsa man akong timailhan nya dra jud ko moagi because the MTU comes to play na. Okay, so mo determine dayon ng MTU nga o diri na lang kaagi kay because it says so. Okay, diri ko moagi because the MTU says so. Mahitabo lang ng MTU if pag-compute tanan sa router natay sila tanan. Okay, napareho tanan ang iyang computation balay. Say for example, serial 000, serial 001, serial 0010. So pasabutan na tulo sila have the same cost. So ang question ana is asa ko moagi? Kay pareho man sila tanan. So dara na mosulod sa MTU. So but don't assume that as soon as you change the EIGRP MTU metric, it changes the interface MTU also. Delay pod. So the minimum MTU path usually equals for the Ethernet interface, which is 1,500. Okay, so mo nang iyang determining factor na kwan, although pareho na sila tan 1,500 bytes kay that would be the default. Depende na sa imong router o depende sa administrator kung saan niya pag-configure. Okay, so that would be the error representation sa ato ang kwan. So what we are going to do is we will try to configure redistribution para kabalo kita kung saan nato pag-redistribute, no, in our classes. This is quite pagtanaw na ko ani pagtrabaho na ko, this is quite difficult, no, but you can still perform this on your own, no? Ay, gi-record ko diri sa baan ni mo eh. Okay. Sige. So this will be the activity that we are going to that I am going to configure. So isend na ni na ko gihapon sa inyong link ani or ang file ani, then you can practice this one. So take note, ASP ako rin ni siya gikuan, ano, ako rin ni siya gipang tawag ni ipang cluster, kay kung ako ni siya ibutang as full blown nya samo kayo. So dire I have only one router sa ako ang OSPF area, so meaning this area here ang tuluan ni is OSPF. So ang backbone usar ka buok, but connected to the backbone is the area 1 na OSPF, area 2 OSPF, then connected also to the backbone na ako'y EIGRP network ug na ako'y RIP nga network. Okay, so mauna siya ang atong i-configure. Okay, pataan na. So what ay problema, no? So let's blow up this one. So what I did is ang akong ibuhat ani is nag-interface configuration ko. So I've done this one already, kitaas kaayo, so taas pa kayo po ng video. So wala naman tayo problema sa interface configuration, right? Like for example, if we are going to perform our interface configuration for this router, tanawon naman nato kung unsang interface na niya, then enable, then config T, then in G0/0, right? 0/0 ana raman ta. Then butan na tong IP address, and IP add, then what is the assigned IP address for this particular router. Okay, then let's do the show run. Do show run. So pasabot ani, I have already configured the G00 of this one into 118.198.1. okay, then the subnet mask will be to 555.5.5.2. wala na dyan problema ni. So Lord, grabe na ning piningkamot na ako og pinasabot sa inyo sa interface configuration, so wala na jud tay problema ani. Okay, sunod, sa ato ang kuan naon nato si area 1. Area 1 has two routers, wala na ako gibutang anong mga PC, although we can still kuan ano kung kabantay ka mo na amoy loop back interface of 5. So that means pwede na to gamiton ang loop back for the purpose of checking if our local area network is working. So moral lang ni siya og a null interface. Null interface wala jud ni siya because it's unsa tawagan ni gani, dili ni siya physical interface but rather a logical interface na pwede nimo ma-turn on if you would like to test something. Okay, to test whether katong imong mga packets can be delivered from one point to another. So i-consider ni nato siya as local area network. Okay, so let's try to put the interfaces here, no? Kung ano siyang i-padaplin mo sa interfaces. Therefore this line here is 210.115.128.240. so it is directly connected to the S010 of our ASBR, and this is the ABR area of the area 1. So tanawan na to kung na-configure na ba. Enable, show, run. Okay, so the gigabit 00 is already configured with 20.15.128.237. okay, kaya 236 man na siya. Okay, then the serial 00 which is directly connected to our ASBR, okay, is configured also. Then basically we have the two connections only. Okay, then this router here, enable, config T, to show run. There we have the loop back 5 of 20.15.128.129. okay, then we have the Ethernet of 01. okay, 20.15.128.238 o 37 na itong bikas, and wala na connection. So that's it. So mana na siya. So basically within this one makaping yun nila, no? Atong kunan sa ping this one to that one. Okay, ping yun na sila, but syempre this router here cannot see the outside router. Ano man, wala may protocol in between. So same is true here at the area 2. Okay, enable, control shift 6. okay, enable, show, run. Okay, at this router here, I have configured already the G00. G00, which is directly connected to the G01 of our ASBR. Okay, with the address of 30.20.224.248. Okay, so 249 dito sa PCAS, 250 siya. Wala tayong problema na. So sa G01, that's 120.25.128.233, then 234 at PCAS. So this will be the two interfaces that we configured. Ano eh? Okay, show, enable, kumani siya, enable, show run. Okay, at this one, na ako'y loop back 6. Okay, I have a loop back 6. Then, gigabit Ethernet 00, which is 120.25.128.234, 233, 234, and maura na siya. Then basically these two routers can communicate. Ping here, P, this one to that one. Yeah, successful. Okay, so going here, take note nga ang atong backbone isa lang, so all connections are present there. So this backbone is area 0 because this is an so tawag na to area autonomous system boundary router. So this is the boundary router of our network padulong adto sa ISP. And what I have configured here are all the connections directly connected to our ISBR. So if we go back, there will be 1, 2, 3, 4, 5 connections. Okay, sa atong i-show, enable, saan naman iyan, okay, enable, show run. So basa kayo, no? Okay, so we have 218.G0 connection, the G01 connection, 2, 3, 4, 5 connection. So 5 tanan ka connection all in all ang atong gikuan. Now take note nga ang kaninga network is directly connected to our ISP, right? So what I did in our ISP is nagatag ng kumudaan og a default route, no? A default route, makibalo jud ang default route na siya because there is no specific na target. And the target is any IP address with any subnet mask. So meaning any siya. And ang iyahang target next hop would be the 198.1. Therefore it's the directly connected port of the PCAS router, of the other router. Okay, so wala tayong problema na. Then going back to the EIGRP network, so EIGRP network is connection 10, okay, connected to the EBR, which is connected also to its own network here with the loopback 0 and loopback 01, loopback 1. Okay, so the address is subnetted. Kung kabantay mo, kasi IDR siya 224.0, okay, 224.64, 128.192.255.0. So meaning ang iyahang network is by 64. No problem. Then sa PCAS network would be the RIP. RIP is directly connected to the network 11.11.11.0. Kani siya would be its IP addressing until sa kwan. So if you can spot that these addresses here are not subnetted, right? How do we know? Wala man dyan siya subnets. Okay? But these IP address are contiguous. Ang contiguous, sunod-sunod na mga daan. So the 1.0, 2.0, 3.0, 4.0, 5.0, so on and so forth. Contiguous siya, although it's not subnetted. So pasabutan imagine na, if I am going to compute an IP address here, imagine na how much did I wasted. Tuwa lang. Sa kaning IP address nga daan, you are going to create pila. No? Kung computer na nimo, that's 2 raised to the power of 8. 2 raised to the power of 8 is what? That's 256 minus 2. So meaning, makakreate ka about 254 IP address minus 2 ka IP address. Kung saan ang IP address na 2? Mauna siya si int SE0/0/1 and int SE0/0/0. Okay? So mao ni siya ang duha ka IP address nga gigamit nato, no? Duha ka IP address. So duha lang gigamit nimo out of 254. So out of 254, 254 minus 2, you wasted about 252 IP address. Mana nga, it would be better for you to use subnetting jud. Bantay mo, kung i-slash pa na nako siya by 30 siguro, slash 30. So, unsa nang slash 30? That is 2 raised to the power of, kung kuwan pa na, no? Kung 30 gi-consume nimo tanan. Diba? Ang nabili nimo, 2 raised to the power of 2 na lang. Okay? 2 raised to the power of 2. Kay 30 na gud ang gikuha nga daan, so di na nimo magamit pang 30, right? Pero napakay 2 nga nabiling ka bits. So 2 raised to the power of 2 is 4 minus 2, that would be 2. So iigo lang 2, iigo lang 2 para sa point to point. So I hope nakita ninyo yung difference between using subnetting, using CIDR, and using VLSM. Okay? So that would be the first procedure that we did, no? So nag-interface configuration lang kita, we've done it already. Then we will perform the protocol configuration, no, for area 0. So ato ta sa backbone, mag-protocol ta dire. Okay? So config T. So how do we perform protocol configuration? Sa tong protocol configuration nato, take note, unsa nga mga networks, unsa mga networks nga naa sa kaning router, mao ra na ibutang nato for our protocol. So that will be router OSPF 1 with the router ID of 1.1.1.1. Always remember nga naa jud na router ID basta OSPF, ha? Then network 10.10.10.0 0.0.0.3 area 0. Then ang sunod is the 11.11.11.0 area 0. Ang sunod is network 210.115.128.240 0.0.0.3 area 0. Then network 30.20.224.248 and 0.0.0.3 area 0. Okay, so tanan nga network ato nang nabutang sa ato ang backbone. Okay, do show run there. So nakay 5. Okay, pero always remember, wala pa nato gibutang si IP route with inside your OSPF. So mo na siyang gitawag nato na muragi redistribute static nato. You get the point? So to redistribute static, ang sa tong command nato ang gamito na ni. Okay? If I am inside the OSPF, default information originate. Okay? So by giving that command, tanang router karon nga directly connected to SPF, yan ang panghatag yan ang i-redistribute also ang imuhang static route. Okay? So no problem. Humana ta sa backbone. Okay? Ito ning butangan og done. Okay. Dali na po sa area 1. So balik sa area 1, ato ni gamiton ang kaninga network. And ato na siyang USPF. Okay? Config T router OSPF 1 router ID of 2.2.2.2. Then we have a network of 210.115.128.240 0.0.0.3 area this one belongs to area 0 pa, di ba? Kani yung pagawas. Then the next network is this network. Imo na ni siyang organization. So meaning that would be network. So kung bantay mo nag-adjacency na siya dito. So 20.15.128.236 0.0.0.3 area 1. Okay, so na kay area 1. So, any question? Wala. Okay, so here, okay, ato sa siya i-configure router OSPF 1 with the router ID of 3.3.3.3. Then atong ibutang ang network na 20.15.28.236.0.0.0.3 area 1. Enter. Then ang sunod is the loop back address. Okay, so meaning we are directly connected to 222 now. Okay, adjacency change, and we are directly connected to router 222, this one, kay router 333 man ta, from loading to full adjacency. So we will perform also the tawag ni the network. Okay, the network 20.15.128.128 0.0.0/27 is 31 area 1. Okay, to show run okay, nana then do show IP route. There, nakita na niya ito ang network. Make this one a little bit bigger. So nantay inter area OSPF na 10 and 11. Okay, sa ring router kay dito man sa gawas, right? So in this case, this is our own OSPF. Asa man tong atong own OSPF. Kita okay. Sumaa sa jud ay. So the 20, okay, dili na to kani siya ang makita niya ang katon ng mga networks, right? Pero kung dili ka lahi man sa di mo makita ang network, so napakita niya sa 30 as 30 nga network and the 210 na network. Okay, so ang dito ni sa gawas, di ba kabantay mo ato nag OSPF sa those are inter area OSPF now. Okay, so unsa man siyang O asterisk E2. So pasabot ani, we have an OSPF with a default static route nga external. Meaning sa external, dili siya part sa ato ang area but a part of the OSPF na network. Okay, that is via this IP address, the 237. Okay, this is the 237 network. So mao na siya ato ang route na mugawas kuno padulong nga diri siya mugawas. Okay, mugawas siya dito sa himong ISP, and this is the ISP, right? Mamantatag libutang na static route. Okay, sige, we'll close this one. Okay, balik ta dito sa ato ang saan man to, this one. So area 1 is done. Let's go to area 2. Okay, area 2 here. So same process, no? Same process lang yapon natin gamiton. So enter, enable, config T, then router OSPF 1, then router ID of 4.4.4.4, then with a network of 30.20.224.248 0.0.0.3 nya area 0 kani. Okay, then the next network is network 120.25.128.232, okay, with 0.0.0.3 area 2 na ni. Okay, so it has been configured already. Alam kasi kaduang router. Okay, okay, enable, config T, then router OSPF 1, and router ID of 5.5.5.5, then network, identify na tong network. This network is this one, so meaning 120.25.128.236 25.128.232 with 0.0.0.3 area 2 na. So ma-up na sila karon, right? Then the next network, okay, that would be the LO. So 120.25.128.32 with 0.0.0.31. Sayop. Kani siya /13 siya. Kani siya /27. Okay, para paan 31. So area 2. Okay, so kung ato ni siyang kuan do show run na anatay network, then do show IP route. Okay, no? So na ko enter area. So how about this? Do show IP route. Okay, so do show run. So na ko'y 30 20 to 24 248 /30. Okay, ang usa ka network is 120 120.25.128.232 0.0.0.3 nya area 2. Okay, nya area 2 sa no. Okay, do show run. Ako lang i-check kay para klaro juga ayo. Area 2 20 nang sa 32 31 sa 27. So ato na siya kuhaan dito. Ano na to kung nakakuan ba, full na ba ta? Do show IP route. Okay, nakoy 20 enter area. Dili niya makita itong usa. Wala niya makita ang katong usa. Ano man? Kaning 20, kanakita na niya. Pero kani, wala niya makita. Okay? Kutob dire ako ning putlon siguro. Then, sumpay lang ako. Check sa nako kung unsay kan. Show run. Do show run. Kay saba kay ngero gihahak na kulang. So, this will be 30 to 450. 50 na dire. 128.233 dire. Okay, 120, 25, 128.233. Check. Do show run. 120, 25, 33 ni. 33, good. It's 120, 234 na dire. /30. Okay. So ako sa rin tantangan ng OSPF niya. No router OSPF 1. We are going to configure this part, the area 0. So enable. config T, then show run, kailangan itong i-identify, do show run, i-identify kung na-configure na ba mga interfaces. Okay, okay. So router OSPF 1, then our router ID of 4.4.4.4 and network of 30.20.224.248 0.0.0.3 area 0 pa ni. So kailangan mo up na siya. Okay, fast forward, up na siya, connected ka sa 1. Then ikaduang network is the 120.25.128.232 0.0.0.3, then area 2 na siya. Okay, wala tayong problema sa first, then kanina po na yung second. Okay, enable config T, router OSPF, okay, do show run, configure na ba ni, yeah, look back and the G00 good. Okay, so ito ganin no router OSPF 1. Okay, okay, we are going to configure the second router now. So enable config T, then router OSPF 1 and router ID of 5.5.5.5, then the network of 120.25.128.232 0.0.0.3 area 2. Okay, so connected na siya. Then we're going to put the network of the loopback address. So network 120.25.128.32 0.0.0.31. Okay, 255 to 24 man na. So 224 minus 256, ha? Ba? 224 minus 255, so 31, right? So that is area 2. Okay, so bisita do show IP route. Okay, sige, tanaw na to dire. Okay, do show IP do show run ta dire. Okay, so do show run ako, na ako'y 10, na ako'y 3, na ako'y 210, 210.115, 30.20.224. Okay, so muna siya akong mga networks karon, no? So let's try to ping. Okay, ping this one to that one, ping siya, no? So i-ping ko na to si Kwan, ping 11.11.11.1. Oh, sorry, do ping 11.11.11.1. Okay, 1, 2, 3, 4, 5. Okay, okay, ping pa dere. Kani siya dili siya makaping because okay, let's check kani siya nga linya. It's 30.224. tingnan siya, no? To show IP route. Two, three, three. 233. Tama? 120, 25, 128, 233. Two, five, two, eight, three, four. Two, five, 50, 20, 2, 4, 8. Ito na siya. Subukan ya. Do show thirty, 20 to 49. G00 G00 ba? G01 G01 tama mo? 30, 20 to 48. 250.250 255 252 G0 sa 0 IP at 30.20.224.250 255.255.255.252 enter now shut and G0/1 IP add 120.25.128.33 255.255.255.252 enter now shut. So in router OSPF 1 router ID of 4.4.4.4 the network of 30.20.224.248 0.0.0.3 area 0. Then network of 120.25.28.232 router SPF 1. Okay, we are going to configure the OSPF of area 2. So enable config T router OSPF 1, then network ID of 4.4.4.4, then network ID network dash ID of 4.4 sama na ini router day sa mukha router ID of 4.4.4, then a network of 30.20.224.248 0.0.0.3 area 0. Okay, then the other one is network 120.25.128.232 0.0.0.3 area 2. Okay, so do show run now nato kung ma-take effect ba. Okay, doon naka network, so basically naka interchange naman ta dire, no? So next is we're going to get the next router here. Okay, enable na router config T router OSPF 1 router ID of 5.5.5.5, then network of 120.25.128.232 0.0.0.3 space area 2. Okay, then network of 120.25.128.32 okay 0.0.0.31 area 2. Okay, so 20, 25, 128, 232 okay 2. So I hope mo work na siya, no? Something wrong here. Na-up akong kwan JSON scene ako. Okay, from 5 na JSON ko pero dire check na do show run 120.25.28.232. Wa naka-connect si Kwan. Ani. Let's try to ping me. Ano ka na? I'm worried. Yan o. Among the agency good. Okay. Do show IP route. Wala siya. Ano naman eh. Do show IP route. Okay, since we have finished already the concepts, so we better configure each of the router here using our what you call this tawag ni kanang topology. Then we have to follow the following procedure here, no, in order for us to configure router distribution to our topology. Okay, so ato lang i-close. I go back to our packet tracer. So this will be the one packet tracer that we are going to use. Okay, um, each of the cluster here includes different protocol. Like for example, at this area here is the RIP network with its own network here. Here also is the EIGRP network with its own sets of router. We have the area 1 here of the OSPF. We have the area 2 of the OSPF, and we have the ASPR here. So each of the router has its own area border na router. especially the area 1, area 2, EIGRP, and the RIP. So here we are going to configure first the IP address. Okay, um, enable config T, then show run. I guess I have already put an IP address here. You show run. Oops. Okay, I already put an IP address. Okay, so pikas na lang ang linya ang wala. So let me see if I have already put an IP address here. No. Enable. So sa ganitong IP address nga ni, this is the IP address that we are going to use, because this is the this is the area where our ISP is connected. So that will be config T in G0/0. So basically we are going to connect this in G00 IP add of .2 255.255 255.252, enter, no shot. Okay, so we are going to connect ourselves with here to S00 EIGRP 10. So in SE0/0/0 IP add then 10.10.10.1 255.255.252, enter, no shot. Okay, so to know what connection we have here, int S001. Okay, so int SE0/0/1, then we're going to put an IP address of 11.11.11.1 to 55.255.255.252, enter, no shot. Okay, so let me see, it's already green. Then connection from here, that will be int SE010. So int SE010, then IP address of this network here, that is 210.115.128.241 255.255.255.252, no shot. Okay, then the other side here we are going to use the G01. Okay, in G0/1, then IP address of 30.20.224.249 255.255.255.252, enter, no shot. Okay, isa pang wala. Okay, so kaning area ato ni configure. So we'll configure first this one. Okay, low, enable, so config T, so in SE0/0/1, and IP address of 210.115.128.242 255.255.255.252, enter, no shot. Okay, in S010, okay, 210 man 241 242. Mano yung nakabati, basta kwan, no? Cluster siya, so we uncluster it first. We uncluster it first para makita na ito kung unsay kwan. To uncluster it, imo siya i-delete, then uncluster lang. Okay, para makita na ito kung asang network siya na belong. Okay, here, so int 001, you know, shot naman ha, do show run int 01. Okay, na to for 1, so meaning int 000 001 man akong gibutang noon. E00/0 oops slash 0 and IP add of this one and no shot. There you are. Okay, because kanipod is we are going to configure po the in G0/0 and IP address of 20.15.128.237.255.255.252. Enter. No shot. So kanipod we are going to configure this one. No enable config T, then in G0/1 an IP address of 20.15.128.238.255.255.255.252. Enter. No shot. So then in LO 5, then IP add of 20.15.128.255.255.255.254. Enter. Oops, 129 sorry, 129. Enter. You don't need to know shot it. Okay, so we put the IP address already for this one, so kanina lang we are going to configure this one. Then low enable config T, then in G0/0 IP add of what do you call this, an IP add, then the IP address would be 30.20.224.250 255.255.255.252. Enter. No shot. Okay, it's green already. Then in G0/1 then IP address of 120.25.128.232 255 oops sorry 233 255.255.255.252. Enter. No shot. Okay, and the other side here, this router, we're going to configure this one also. CLI and no enable config T, then we are going to configure the in G0/0 IP add of 120.25.128.234 255.255.255.252. Enter. No shot. Then we're going to the loop back address in LO6, then IP add of 120.25.128.33 255.255.255.27 is 224. Enter. No shot. Okay, so since we have already finished the putting up interfaces, no, interfaces is already done, in which in the other in the EIGRP and in the RIP I put interface configuration already. So this time we're going to put the protocol. Okay, so now na to si backbone value show run. So kung tanaw na to, no, there's no protocol set up yet. So to put the protocol, ang yung buhaton is kani sila tanan, which is part of, diba, part man sila ni this one. Kaya ako ni siyang isulod na karon sila ha. So this one here, okay, rasterize na ako. Okay, there, para pag sulod na ko, kita na ko mauna ni siya ang iyahang mga protocol. Okay, so ato ni siyang router OSPF 1, then router ID of 1.1.1.1, then the network of 10.10.10.0 to then 0.0.0.3 area 0. Okay, and the other one is 11.11.11.0 area 0, and network 210.115, 0.128.240 0.0.0.3 area 0. Okay, then network 30.20.224.248 0.0.3 area 0 there. So exit, do show run. Okay, so we have already so this is where we are going to put now inside our OSPF. We are going to redistribute the what they call this, the static route. So giving the command for static route, so router OSPF1, all you have to do is to give the command default information originate. Okay, by giving the command, the OSPF now will distribute all the static route to each of the areas which directly connected to that protocol. Okay, so let's try to configure this one. So in our list here, we have done already configuring the protocol for OSPF. So done na niya. So we have to work on with our area 1. Okay, so here, so what we are going to do is what do you call this, router OSPF1, then we are going to put the router ID of 2.2.2.2, then the network which directly belongs to area 0, which is 210.115.128.240. Okay, 0.0.0.3 in the area 0. Okay, so basically this area now is the connected. So what we are waiting is itong iyahang what do you call this, lugay kayo yung tawagan niya, then 210.115.128.240. so the other side ABR 210.115.128.240 area 0. So what I am waiting is kinanglan mo connect na sila. There will be adjacency already. Wala lagi adjacency ka na butang. Maybe I'm going to stop kay murag